Welcome to this video, where you will learn how to perform vector queries, including using pgvector for data queries. After watching this video, you will be able to describe some of the requirements for querying vector data, explain how to write a TS query to search a TS vector, identify the special operators used in PostgreSQL, describe how to perform searches based on cosine similarities and distance between vectors, and explain how to restrict a search using a threshold value. Writing queries in the PostgreSQL vector database is very simple and not very different from well-known SQL queries. However, since the vector data type exists as is just a massive float array, retrieving this data type as is does not provide any human understandable output and defeats the purpose of using vector data. To find the distance or similarity metric between two vectors, the vectors must be the same length. It is important to use the same model for generating the embeddings stored in the database and for generating the embedding for the search query. Otherwise, using inconsistent models can yield unexpected results. TS query is specific to the TS vector data type. This data type can only hold strings, and a string can be a huge natural text document. You can retrieve one or more texts in PostgreSQL RDBMS as a document and search through the same document. TS query contains search text that consists of normalized lexemes, and you can use single or multiple terms. You can combine terms using operators such as and, or, not, and followed by. You don't even have to specify the data type of a column as TS vector. You can search through a text in any string by retrieving it as a TS vector and using a TS query on this string. Let's understand this better with an example. Here, the string, a red mat costs as much as a blue mat, is being searched for the presence of both mat and red. This query returns true. If you need red to be followed by the mats and not just randomly appear anywhere, you can use the followed by operator, which looks like this. However, you can only use TS vector to search for text. For other kinds of data, including text data, you can use pgvector. You can measure distance and similarity metrics multiple ways using pgvector. Depending on how you want to measure the metrics, you have three search operators. Let's address three widely used operators. The first operator, which uses a left arrow, a hyphen, and a right arrow, is used for L2 distance, also called Euclidean distance. The second operator, which uses a left arrow hash symbol and right arrow, measures negative inner product, and the final operator covered here is the cosine distance operator, which consists of a left arrow, an equal sign, and a right arrow. Depending on the circumstances, some distance and similarity metrics are more precise than others. Let's examine some examples of using these operators. You have the goal of obtaining 5 reviews similar to the first review, and you will use the following select statements. Notice that the select statements return the results based on the embedding. By default, the order is ascending, which means the first ID displayed will be the embedding with the shortest distance. First, use the operator for Euclidean distance. Select all columns from the reviews table where the ID does not equal 1. Order the results by the Euclidean distance between the embedding column and the embedding of the row, where the ID equals 1, and limit the output to 5 rows. This next query uses the inner product operator to retrieve records based on their distance. Select all columns from the reviews table where the ID does not equal 1. Order the results by the inner product between the embedding column and the embedding of the row, where the ID equals 1, and limit the output to 5 rows. And this final query uses cosine distance to also retrieve the records based on their similarity. Select all columns from the reviews table where the ID does not equal 1. Order the results by the cosine distance from the embedding of the row, where the ID equals 1, and limit the results to 5 rows. While the preceding search operations explained results based on the distance or similarity, to validate your results, you'll need to create a query that retrieves comparative records that have very little or no similarity, even though it doesn't make sense to retrieve such data. When running these queries, you'll want to set a threshold value so that unless the distance or similarity are within the threshold, you will not find a match. You can use a select statement and specify the threshold value. The following query returns records when the distance is less than 5. You can also apply thresholds using a variety of operators. In this example, you apply Euclidean distance to search for matches and select the 5 closest results. In this video, you learned that use the same model that you used to generate the embeddings for data to generate the embeddings for the query. Use the same model to generate the embeddings that are stored in the database. TS query contains search text based on normalized lexemes using single or multiple terms, including operators such as and, or, not, and followed by. PostgreSQL can use the operators for Euclidean distance, inner product, and cosine distance. When running queries, set a threshold value that unless the distance or similarity are within the threshold, you will not find a match.